Okay. I'll try to make it so that you guys can see what I'm doing all along. So these are my chemicals. I got cebacol chloride, dichloromethane. These are mostly empty at this point, but I've got enough here for, I'd say, 2 more demonstrations. This is my hexamethylene diamine, and I'm just going to put water in with it. Put some water in this one. Okay, that's just water. Just to show you quickly what this is. The cebacol chloride here, it's got 10 carbons. It's got a double bonded oxygen or chlorine at the end here. It's going to dissolve in dichloromethane, and that's going to form the bottom layer. This here, the hexamethylene diamine, it's got 2 amine groups at either end, and it's going to dissolve in water. It's going to be the upper layer. Now, between the 2 of them, it's going to form a layer of the polymer nylon. And that layer of nylon is going to prevent the 2 layers from touching each other. It's sort of like when you have aluminum will rust to form aluminum oxide, and then that layer of aluminum oxide will prevent the rest of the metal from rusting through. Sort of a protective coating. Well, that layer of nylon in between the 2 layers is going to prevent the 2 layers from reacting with each other. But then I'm going to take a pair of tweezers, and I'm going to pull up the nylon, hopefully from the center. I could do it from anywhere. Pulls up. I'm going to try to make a really, really long string, sort of like a nylon guitar string. And as I pull it up, the edges are going to get exposed, and then it's going to be able to react where the 2 liquids meet. It only reacts at the interface between the 2 liquids. So here we go. I'm going to start with the cebacol chloride here. And that's not clogged. Just a 1/2 milliliter. You will notice that this dangerous chemical is fuming. See the vapors coming out of it? Okay, I'm going to put 10 milliliters of dichloromethane, which is commonly used. Kids usually see this when they look at a caffeine extraction video. Nile Red has a great series of caffeine extraction videos. They all use dichloromethane. Okay, I'm using more than I need. I want you to be able to see it, so I'm using plenty of this. Okay, so that is my cebacol chloride dissolved in dichloromethane, swishing it around so that it all mixes. That's going to be my bottom layer. Now, I got some water here. Let me add just a little bit more water. Add another 5 or 10 milliliters of water, and in that I'm going to put some of this. So this one still has some in it. Not that much, just a little bit. You're going to see that even though I used very small amounts of these chemicals, I'm going to get a very large yield. Now I'm going to put my hot plate on. I don't want it to get too hot. I don't want it to get too hot because the dichloromethane is very volatile and it will boil if it gets too hot. I don't want it to boil, because if it boils, it's going to mess up that interface. It's going to mess up that layer of nylon as things blub through it, and then the whole thing is going to become a big glob of nylon. I want to avoid that. Okay, other things I want to avoid. I want to pour it on very slowly. And I'm not using a water bath for this because I don't want it to be tilted. I want it to be level. I'm going to pour it on very slowly because I don't want the force of the liquid of the water with the hexamethylene diamine to break the layer and cause it to be a big glob of nylon. So I'm pouring it very slowly. You can already see that nylon has formed here. I'll move the document camera in a second so you can see it. I can see it already. Take a look from above here. You could already see that there is nylon. Focus that. I'm going to leave it for a little bit Again, I don't want it to be too hot, but it works better if I have a little activation energy. Okay, and I'm going to bring the document camera down here, and I hope you can see there are 2 layers here that have formed. Okay. Let me point at it with the tweezers here. There's a layer that stops right about there, and then there's a layer above it. You're going to see some nylon has formed that has kind of gone above it. As careful as I was, some nylon will initially react, and if you aren't too careful with it, it will form. I'm just going to give it about another 30 seconds on the hot plate. Again, I don't want to see it boil. That's what I'm avoiding, trying to avoid. But it does work better with a little heat. Okay, as soon as I see a bubble form there, I know it's time to take it out. Turn off the hot plate, and now I'm going to try to get a view from right above. So I hope you can see that some nylon has already formed. You see it's all on one side? That's the side I poured it in on. And now what I'm going to do is I'm going to grab that. I'm going to try to wrap it around this stirring rod, but I'm going to use tweezers. I actually have 2 pairs of tweezers because I've learned from experience that sometimes it will slip out of the first pair. Okay, now what you're going to see is once I pull up the initial piece of nylon, it's going to form a long string, sort of like a big piece of mozzarella that you're pulling all the way up to the sky. It's going to go so much that I'm going to try to wrap it around the string. It's going to be a wet piece of nylon. It's easy to break it because it's really only 1 molecule thick. There are probably a few strands of nylon that are created there, but it's still going to be fairly fragile. Nylon is very strong when you wind it or weave it, but it's not so strong with just 1 strand. So here we go. You're going to see like a star-like pattern form on the bottom here as nylon is formed and pulled up. Hold on, I don't want to drop this. Okay. Do you guys see that star down there? Do you see what I'm talking about? Document camera's getting in the way of me pulling this up. Look at this. Whoa! I didn't want that to happen. Okay, well, I messed that up a little bit. I should have started wrapping it around sooner. But I can catch it again. Just have to get all the pieces I broke off first. So watch, I'm going to catch it again, and now I'm going to pull it up again. Now I'm going to wind it around. Do you see that star in the bottom? Take a look. It's kind of surprising how much product I'm going to get from such a tiny amount of reactant that I used. Oh, it broke it again. From above. Oops. Eventually I will run out, but it's kind of surprising how much nylon is going to be made. This is, right now, wet plastic. After a day it will dry. There are things that you can add to make it stronger, which are called plasticizers. You can make it stronger, you can make it more flexible. There's a whole lot of chemistry behind plastics. Okay, I think that's probably good for now. Let me see if I can get a little more going. We're probably at the end of it here, but we got a nice little wand full. Here I got from another period, and here I got from first period. And so there we go, nylon. That's my demonstration. There we go. I think that ends it. That actually, there's more, but it broke apart at this point. So there we go. My nylon that I created from the polymerization. Okay. I'm not going to eat it. No. Okay, thanks.